Next, I will explain some common statistical plots and how they can be generated in Seaborn. To demonstrate how to generate plots in Seaborn, I'm going to create a new Python notebook called viz. We then import necessary Python libraries and load the two datasets you are already familiar with. I need to merge the airport data frame to the flight data frame, df. This is the resulting data you already know from earlier. First is the king of all plots, the bar plot. The bar plot is probably the most used kind of plot. It is used for comparing different amounts. The figure on the left shows a simple bar plot, while the right-hand side plot indicates error bars showing variations due to other features. To create a bar plot, we first get the top 10 airport and top 20 aircraft types outside of the United States. Then we query the flights only for this airport and carry out by the top 20 aircraft types. Finally, to prepare the data for the first bar plot, I generate the data containing the flight count per aircraft type. With the Seaborn bar plot function, we can provide the data, the feature for the x-axis and feature for the y-axis. And voila, we get a not so bad looking bar plot. First, let's remove the unnecessary color coding by making everything blue. I also like big figures which have better resolution for scientific papers or reports. Let's change the size and assign better names for the both axes. The new problem now is that the font is too small for my liking. So I will set the matplotlib font configuration with a new size of 16 points. I also like the Ubuntu font over the default matplotlib font, so I will just set that as well. Now running the bar plot again, I have a nice plot, which is much more clear. The second bar plot will show the flight count per aircraft type, considering different countries. For that, I group the flight by type code and country. Then I create the bar plot. With the same feature for x and y axis, the error bars are shown. This represents the variations of the same aircraft type among different countries. Line plot is often used for showing trends, especially trends between two discrete data points. Here you see three line plots showing the number of flights departing from an airport. The first one shows the departing flights during a 24-hour period for all Mondays. The second one shows a confidence interval considering the variation over different weekdays. The last one shows two different groups indicating the number of departures and arrivals at the same time with their own confidence intervals. With a line plot, I want to show the trend of number of flights at Amsterdam Airport over the 24-hour period. This block of code allows me to get such trend for both departure and arrival for different weekdays over the entire month. The simple line plot looks only at departing flight numbers on Mondays. We can quickly visualize the trend by providing the feature x as hour and feature y as count. The extra statements make the plot larger with better labels. Next, we use all the data for generating a line plot. Now the result also includes a confidence interval, including variation in both departure and arrivals, as well as variation across different weekdays. Next, I want to separate the arrival and departure flights and see how they are related to each other. In this plot, we can simply specify the hue parameter as kind, indicating whether a flight is departing from or arriving at the airport. Now we have the two different trends representing in the same figure, using line plots with confidence intervals. Another common statistical plot is histogram. It shows the distribution of a value for a certain parameter. I'm sure you're all familiar with histogram. In Seaborn, there is another similar plot, kernel density estimation plot, also known as KDE plot. It estimates and shows a probability density function based on the data. Box plots are used to compare distributions. Here we are showing the variation in number of flights per hour across different airports. Similar to the previous line plot example, we can also display two groups side by side. In this case, the number of hourly departing and arriving flights per airport. It is a common task to visualize distributions in Seaborn. For this task, I'm interested in the top 15 airports. You can see most of them are from the United States, indicated by starting airport code K. I use this block to obtain the number of departing and arrival flights by hour for these airports. The data to be visualized is presented here. It includes the hour, the number of flights, the airport, and the type of flight. This block of code contains a boxplot function, which shows the flight number for all airports across different hours of the day. We specify the X feature as airport and Y feature as count. So the boxplot is presented vertically. Next, if I specify the hue parameter again, I will get a grouped boxplot, which shows the departure and arrival boxplot side by side. Similar to the boxplot, the violinplot can also visualize distributions. Instead of showing the descriptive stats, the violinplot uses kernel density estimations to approximate the probability density functions. Sometimes it can provide an elegant way of showing two groups of related distributions, like the one in the second figure here. Similar to the boxplot, we can visualize different distributions with a violin plot in Seaborn. The code is almost identical except that the function name. And that's the final result. When showing the departure and arrival stats side by side in the violin plot, we can again assign a hue parameter. I set split to true here and give it a binary categorical color map, set2. The inner quantiles parameter allows quantile lines to be drawn in the violin plot. Then I reformat and run the cell. And finally, we have this nice grouped violin plot with indications of quantiles. If you want to show distributions of two related parameters, the joint plot is the best choice. In this slide, you can see two different representations of the joint plot. The first one is similar to the one-dimensional histogram, while the second one is two-dimensional kernel density estimation plot. Joint plots allow you to visualize correlations between two different features. To demonstrate the KDE plot, I'll recall the calcDistant function. We calculate the duration and distance for all flights departing from Amsterdam. Then I want to plot the distribution of a duration using the common histogram. I specify the beam width parameter to 30, which grouped flight duration with 30 minutes intervals. Now we have the histogram. Similarly, we can generate a KDE plot. We can see the result is consistent with the histogram. Next, I want to show the relationship between duration and distance by using the joint plot from Seaborn. I specify the duration and distance as feature for the x and y axis. The resulting figure shows two histograms on both axes, and the relationship is shown in the scatter plot. Apparently, the scatter plot is not the best choice here, since there are many overlapping points. We can replace the kind parameter to KDE, so to show the 2D KDE plot. This process takes a bit longer, since the Seaborn has to perform the kernel density estimation first. Once it is complete, we can see the contour plot in the center and a single KDE plot on each axis. The last example I want to show you is a relational plot in Seaborn. This can be used if you want to visualize the same parameter over different groups. The relational plot automatically generates different subplots and ensures consistent ranges for the axes for different subplots. In this demonstration of the relational plot, I want to show the hourly trends in departing and arrival flights across major European airports. These are the top airport codes I'm interested in. The structure data is the same as the one for line plot. With Seaborn real plot function, we need to specify extra parameter. That is a column feature. This way, each small plot in the figure represents an individual airport. If we run this code, we get only the scatter plot in one row. This can certainly be improved. First, I want to have 2 rows, that is 4 columns per row. And I also would like to use line plots instead of the default scatter plot. And finally, we have a nice relational plot showing flight trends across the top major European airports.